Hey there, CJ Math students, and welcome to Notes 1.8. The key idea that we're discussing today is rational numbers can be expressed as fractions, decimals, or percentages. So we can write a rational number in three different ways, and it will still mean the same exact thing. This is called equivalency. So here, if I give you a fraction, I can tell you how to make a decimal out of it or a percent. Same thing. If I give you the decimal, I can tell you how to make a percent or a fraction. And if I give you a percent, you can still make a fraction or a decimal. No matter what, if I give you one type of rational number, you can give me two other types of rational numbers. So there are multiple ways to convert fractions to decimals. The first one is just simply divide the denominator into the numerator. So we'll take 10 and we'll try and divide that into 2. And obviously we can't do that, so because 10 is larger than 2, so we say decimal, decimal, and we'll add a 0, and then 10 into 20, that obviously goes in there 2 times. Nothing left over. I know I'm done. 0.2 is my answer. Let's try a little bit more difficult one. Let's go 8 into 5, or 5/8, right? So 8 gets divided into 5. Can't do that, so I say decimal, decimal, 0. It's important that you put the decimal right above in the division bar. So 8 goes into 56 times, because that's 48. I have 2 left over, so what does that mean? I put another 0 and I shoot it on down, right? 8 goes into 22 times, that's 16. I have 4 left over, so what do? I put another 0 and I shoot it all the way down. Promise this will end. 8 goes into 45 times, and you'll notice that's exactly 40. I have nothing left over, so 0.625. 5/8 is 0.625. Okay. Option 2 is, if you can, make the denominator 10, 100, or 1,000, aka what I like to call base 10. So 14 over 20. What I can do is say, okay, how do I make 20 10? Oh, I just multiply that by 5, right? Multiply 14 by 5. When I do that, I get 70 over 100. Now, I could also, if I wanted to, divide by 2 here, because if I divide by 2, I get 20 divided by 2 is another base 10, right? 10. And 14 divided by 2 is 70. 70 over 100 and 7 over 10 are the same thing, right? This is 0.70, and this is 0.7. If I just tack on a 0, they're exactly the same. They are equivalent. What about, let's try a difficult one here, 125 and 250. Well, remember, 25, right? 25 cents is like a quarter. So basically, if I just multiply by 4, I will go ahead and get something that is over 1,000, right? And if I do 125 times 4, I get 500. All right, so my answer is 500 over 1,000. Or if I simplify that, notice I can divide by 500, because 500 exactly 1/2 of 1,000. I'll get 1/2. Now, if you are sorry, that we weren't trying to make a fraction out of this, I'll basically just equal 0.500, right? Anything over 1,000 or 100 or 10, you can just look at the numerator and say, okay, that's my decimal, right? 120 over 500, right? I just can multiply that by 2, and that will give me something over 1,000, right? 500 times 2 is over 1,000. 120 times 2 is 240, so my decimal is 0.240, or just 0.24. Okay, special note. Repeating decimals are decimals that go on forever, and we write a bar over the top of the last place value to state that. So let's again try, and since I can't make that a base 10, 3 gets divided into 2, and I say decimal, decimal, 0. All right, 3 goes into 20 6 times, that's 18. I'm left with 2 left over, so I add another 0, bring it on down. 3 goes into 20, oh, look at that, 6 times, that's 18. I'm left with 2 left over, get another 0, bring it all the way down. 3 goes into 20, up 6 times, that's 18, and this is just going to keep on repeating. I'm just going to keep on getting 6. So my answer here as a decimal is 0.666, and over the last one, I say repeated. That bar over the last digit is repeated. Okay, I'm going to have you finish up this front side with the rest of these in Ed Puzzle. It's the end of part 1.